or go to math.com, practicing some calculus or learning it. I believe we're in section 16 here. Yes, 16 dash 1. Want to find the derivative. We got y is equal to 11 raised to the x power. I don't need to write that down. We can remember that. Y is equal to 11 raised to the x power. Now, in the previous section, this was an e right here. And this is not much different, except we're going to add something that we didn't show in the previous section. So let's just do it. We got y prime is equal to, so we do the same thing. We take the derivative of the exponent, and the derivative of x is just 1. And I'm going to put a parentheses around that because that's going to get confusing when I write the 11. And then we just rewrite the whole thing. But now out here, we're going to write the natural log of whatever this number is, the base. Call that the base. The natural log of 11. Now you might be asking, why, when we had this right here, why didn't we write the natural log of e? Well, here's the reason why. Let's take the derivative of this. So the derivative of x is 1. We rewrite times, and now I say the natural log of e. But guess what the natural log of e is? Well, the natural log of e is just 1. So that's the reason we didn't write it, because the natural log of e is 1. And what's the sense, right? What's the sense in that? But this is actually a very interesting one here. If you noticed, we end up with the function y. We took the derivative of it and we just get the same thing back. Now that's really interesting, especially, I've kind of got off on a tangent here, especially if you looked at the graph of this thing. And okay, so this is our x value, and let's say this is our y. And when we plug x into this, for example, let's say it's 1, we get e out, right? So right here. But what's even more interesting, of course that's not very interesting, but what's really interesting about it is when we take that 1 and plug it into here, it turns out that now, whoa, I just noticed something. That is a serious mistake. This graph actually does this, not that. And the reason I knew that real fast is because when I go to plug 1 in, e raised to the 1 is like 2.71 yada yada yada, which is a positive number, and the slope of this tangent line is negative. So we're not getting a negative number out, so something's wrong, right? This is actually the graph of this function right here, where if we plug 0 in, we get 1, it crosses here at 1. Okay, I don't know what I was thinking about that. But anyway, what's interesting is when you take some number like, for example, 1, and you plug it in to here, you get 2.71 something, and it turns out that this y value here is actually the same thing as the slope of the tangent line. So because its derivative is the same as the original function itself, right? That's what really makes this really unique. This e raised to the x. Well, we have totally got off on a tangent on that. But let's just go back to this. So y prime is equal to, and it doesn't matter how you write this. You can put the natural log out here or whatever you want to do. I'll just put it here. Okay, so there it is, and we are done. We're done. We're done. Okay, we're finished. I'm not sure what's going on with the help here. Oh, okay. I see. Yeah. Natural log. All right. Okay, and I shall see you there.